Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, today we will discuss about DAG in Spark. So what is DAG? A direct acyclic graph is the full form of DAG, is a data structure used in Apache Spark to represent the flow of operations or computations in a job. Means when you submit a job, right, when you are submitting a program through a client, the driver will be created and a Spark session will be instantiated and the Spark session will handshake with the cluster manager and negotiate the resources, and that's how actually the procedure will start. Here when we are sending some job to client, the client will send that request the driver to execute any program. So that driver with the help of Spark session, it will create some logical and physical plans. That's where this DAG will be generated, and based on this DAG the procedure execution will happen. Like it will know what all the nodes, we will see what is a node and all, okay, in some time. So what all steps, what all transformations we need to execute as part of that particular application. So that we will come to know, I mean the cluster manager will come to know from the DAG. Okay. So what is a DAG? It's a data structure used in Apache Spark to represent the flow of operations. What all transformations we are using in this job and what exactly it needs to execute. Okay. And DAG is, as we said, the name is suggesting that it's a graph. So it is a collection of nodes and edges as any normal graph, and where nodes represent the individual operations and edges represent the dependency between them. So DAGs ensure efficient and optimized execution of complex workflows. That is what is DAG, the definition of DAG. So why do we need to use this DAG? What is the purpose of this DAG and what are the benefits of DAG in Apache Spark? So the primary purpose of this DAG is to optimize the execution of data processing tasks by leveraging this parallelism, pipelining and lazy evaluation. So by referring to DAG itself, we will understand where the job is taking some time, what all transformations it is trying to execute. Okay, so that kind of help it does to us. Like optimization is the main usage that we as a developer that we use the DAG, like what how the flow, how the transformations flow is happening for any job, and is there a scope for the optimization. So that's where we mainly concentrate on DAG. Okay, when a job is running, we will go to the UI and check the DAG to analyze whether all the transformations that we applied, the transformation flow is happening properly or not. How to optimize, where is the scope of optimization, means is there anywhere the job is taking some time, and also it also shows the number of records it is processing. There itself we will get to know how many records it is processing as per that transformation. Okay. And lazy evaluation, here the meaning is, you know, the normal lazy evaluation, right? Spark, when you are giving, like you have a data frame and you have lot of transformations applied on that data frame. Okay, but that particular transformation, the compiler will not execute these transformations then and there. It will just note down the flow in a form, in the form of DAG, and it executes that transformations only when an action is triggered. What is this action? Action is another operation, okay, which will communicate with the driver, which will share the results with the driver. That is called as action. So until and unless any action is triggered, these transformations will not be executed. This is called as lazy evaluation. So how we will come to know about the lazy evaluation is DAG will note down each and every transformation. It's still acyclic. It's not cyclic. That's why there is a name called acyclic. Means it will not go back to the starting point again. It's a one flow, like one sided flow. It will go from one top to bottom. Okay, that kind of flow will be there. That's why it is called as acyclic graph. And when it shows the step by step procedure of each transformation that we are applying on the data frame. Next, what is the benefits? Means it includes the improved performance. So of course, right, when we know that where the job is taking some time and we are able to pinpoint the what to say, the command which is taking some time, and there is a much scope of optimizing that one, right? So with that we will have improved performance. Okay, and then fault tolerance. So what is fault tolerance? Let's say you are running a Spark job and in between due to some issue the job is aborted. So usually in any other language we will lose that entire calculation and the compiler has to start from where it is starting. Like from the starting it should compile it. It should calculate it will compute all the data frames. But whereas in DAG what will happen is in one node, in one of the nodes, if any failure in one of the nodes, then it will recompute based on the latest available node. Means it as the data frames are RDDs are immutable, right? So it will have the computed RDD or data frame available till the last failure step. From there it can recompute. It doesn't have to go back to the starting point and regenerate the calculations again, but whereas it can go to the previous node, previous successful node, and then it can calculate the values. It can compute the data frames from there. So this is what is the meaning of fault tolerance. Like in case of failures, we don't lose anything. It will have the latest successful step available. From there, it will recompute the data frames from wherever the last successful step. Okay, that way we will not lose the data, and also we will save the computation time. Okay, so and automatic optimization of the execution plan based on the data dependencies. This anyway advantage of using Spark, right? It when we are giving some query for compilation, it will not blindly execute, whereas it will apply some optimizations on that query using the catalyst optimizer. So it will just rearrange the query that we are sending, and it creates the physical plan which is a winner of the physical plan, and then it will apply the optimizations, and it selects the cost effective physical plan, then it will take for execution. Correct? So this is the purpose of the DAG and benefits of using the DAG. So this is how a sample DAG looks like. So where you can see this, you when the job is running, right, when the or even after the job completion also, you go to the Spark UI. Either if you are running locally, just use localhost and 4040 or some localhost, you can just go there and check it. Or if you are working in a cluster, you go to the cluster UI, Spark UI, and click on that application ID, and you will be able to see one kind of page where you have these stages, jobs, executors, and storage, SQL, all these tabs. Okay, when you click on SQL tab, you will be able to see the DAG while the job is running. If not, go to the stages and click on any completed task or ongoing task. You will be able to see this kind of diagram, which is a DAG. So here if you see, right, it has the stages mentioned. So we have already discussed what is a stage and all that, right? So I'll just summarize. Whenever any action is performed, I mean, how many actions are there? Those many jobs will be created internally. For each job, a minimum one stage will be created. Inside that stage, if there is any wide transformation, then new stage will be generated. Otherwise, if any transformation is a narrow transformation, then only one stage will be created. So all the narrow transformations you are giving one by one, right? I mean, when you are applying on a data frame, then only in a single stage all the narrow transformations will be present. Until and unless if you have a wide transformation, then the new stage will be created. Okay, so this is how the DAG looks like in the cluster. Next, what all the components available in DAG means? This one is vertices. So, vertices represent the individual operations or tasks in the DAG. So, in that each vertex corresponds to a particular computation or transformation applied to the data. Then it will have edges, means every graph will have these edges, right? So, edges represents the data dependencies between the operation, means they define the flow of data from one operation to another and ensure that dependencies are satisfied during the execution. Okay, and then this will have stages, as I said, right? In the previous diagram we have seen what is a stage, right? So this is a stage, and inside this stage we will have the tasks. So what is the stage? Stages are the logical units of execution in a DAG. They represent set of tasks that can be executed independently based on the data dependencies. Stages enable parallelism and efficient resource utilization. Okay, and then inside the stages we have tasks. Tasks are the smallest unit of work in DAG. So they are individual computations and that can be executed in parallel. So tasks are assigned to the workers in the cluster for execution. So this is where these tasks will be executed in the executors, and that is where the execution will happen. Clear? Next, so how DAG execution works in Apache Spark. So what exactly will happen is, first it will create a logical plan. So this DAG is constructed by representing a high level data processing operation such as the logical transformations, means it will not have code. It will just have a read operation, then filter of operation, and then group by, and then order by, and then count, whatever it is. So it will be like just the high level transformation or operations will be mentioned in the DAG. And this logical plan is a structured representation of the desired computation. That's why it will have, the DAG will have only the logical plan, means high level logical plan details, which means that it's a structured representation of what operations that we are performing. And also next is the optimization. So the DAG is optimized by applying various optimization techniques such as rule based optimization, cost based optimization, and pruning any unnecessary operations. As I said, right, when you trigger a query, it will not simply blindly execute that. Okay, it will rearrange it. It will remove unnecessary filters. It will remove unnecessary joins, and it will rearrange the query properly so that it will become optimized query. Okay, so this step ensures the efficient execution and minimize the unnecessary computations. Okay, and finally physical execution. Then this DAG, once the first logical plan will be generated in the DAG, right, means the high level plan will be generated and it will be optimized and rearranged the steps in the DAG, and then finally the DAG is converted into physical execution plan, specifying the actual sequence of tasks to be executed after the rearranging in the previous step. The plan takes into account the available resources, data locality, and other execution constraints. Everything it will consider, and then finally it will send for the execution. Okay. So, what are the examples of DAG operations in Apache Spark is usually, like, it's not an example we can consider. We will use this. The DAG is used in all this streaming, machine learning, and graph processing. Everywhere, wherever we use the Spark, right? So, DAG will be created and it will help us in all the we have discussed about the advantage and benefits of this, right? It will be helping us in all those things. Okay. And coming to the what is the importance of DAG is like the DAG plays a crucial role in Apache Spark data processing engine. It enables efficient execution of complex data workflows, improves performance, and enhances the scalability and reliability of big data applications. Okay, this is about the DAG, friends. Thank you for watching the video. Hope you liked the video. Please subscribe to my channel for more interesting learnings. Thank you.